Hey, welcome back. So in the previous lecture, we explored about the HSC connection, right? Let's explore about HSI. Now let me take you to the HSI section of the reference manual. So here it is. So the reference manual says that the HSI clock is generated from the internal RC oscillator and its value is 16 megahertz. This number may not be true if you are using some other microcontroller from ST. So if you are using a microcontroller from different families such as F1X or LX or HX, so you have to verify this number by reading through the reference manual. And please note that HSI is a default clock for your microcontroller when the microcontroller undergoes reset. So microcontroller, when it undergoes power on reset or system reset, the microcontroller will get started with HSI clock as its main system clock. So later through your code, you can change the clock to something else, like you can change the system clock to HSC or PLL. So now if you take a look into the HSI configuration here, and you can see that the HSI line is coming from this block, which is internal to the microcontroller. So this is a multiplexer which is there inside the microcontroller. By configuring this mux, you can select one among these as the clock source. So as I said, after system reset or after power on reset, so microcontroller's design will automatically select HSI as the main clock source. So that also means that until you do any code settings, HSC and PLL are ignored. So those are disabled. So you have to enable HSC and PLL through your code. Until you do that, HSC is dead and PLL is also dead. So that's the reason, even if you don't use any crystal for your microcontroller, you can run your microcontroller using the internal RC oscillator. So that's the beauty of this microcontroller. You need not to connect any crystal. So now here you can see that the HSC is actually not highlighted, right? So you cannot select this radio button, right? You can switch to PLL here. See here, you can switch between PLL and HSI, but you cannot select HSC here. For that, you have to do one settings. You have to go to pin configuration here and go to system core and go to RCC. And here just select how HSC is connected on your board. HSC is connected as crystal, not as bypass clock source. For Nucleo, it would be bypass clock source, right? For our board, it is crystal. That is for Discovery board. Let me select crystal. Now let me go back to the clock configuration. Now you can see that I can able to switch between HSI, HSC and PLL. So the main clock of the microcontroller is system clock, denoted by the word sys clock. And in this configuration, you are seeing system clock is actually derived from the HSI, right? So that's a default configuration for the microcontroller after reset. So that's what I said. Using this system clock, clocks for various other domains of the microcontroller are derived. So for example, take a look into H clock. H clock stands for HB clock, right? So this is a main clock which governs the HB bus of the microcontroller, isn't it? This clock is derived from system clock, but in between there is a prescaler, HB prescaler, which is used to divide the sys clock. So because its limit is 168 megahertz for this microcontroller, right, for the H clock. Suppose if sys clock is 400, then you should use a HB prescaler to divide that system clock to bring the value lesser than this value, right? So that's the reason why HB prescaler is required there. By using this H clock, you can see that clocks for other domains are derived. For example, let's start from Ethernet. The Ethernet peripheral, you can see that it doesn't depend on H clock. It directly taps the clock from sys clock itself. So that's why this prescaler has no effect on the operation of Ethernet. And after that, H clock to HB bus. So as I said, HB bus runs using this H clock and all its associated peripherals such as GPIOs, camera interfacing, memories, etc. So that means the HB domain peripherals are clocked by this H clock. You should remember that. So one example is GPIOs. So GPIOs are actually clocked by H clock. Remember that. And let's move forward. So here you can see that 2 Cortex system timer. There is a timer called SysTick timer inside the ARM Cortex M3 or M4 processor. And now clock for that timer is also derived from H clock, but using this prescalar in between. So you can divide the H clock here. And after that, this H clock also goes directly to the processor here as F clock, Cortex clock. So that's why you can say that your processor runs with the speed of H clock, and there are no prescalars in between. And after that, clocks for APB1 domain and APB2 domain are also derived from H clock, but using these prescalars. Why? Because there is a limit for APB1 bus and APB2 bus, right? So APB1 bus cannot cross 42 megahertz and APB2 bus cannot cross 84 megahertz, right? So that's a maximum limit imposed by the specification or from the microcontroller design. So that's the reason why they have given these prescalars. So if it is necessary, then you have to divide the clock using these prescalars. So all the peripherals which are connected to the APB1 bus, this is the APB1 bus, right? And there are various peripherals are connected like timers, UARTs, SPI, I2C, CAN peripherals. So all those peripherals are actually clocked from P clock 1, which is derived from H clock using this prescalar. And all the peripherals which are connected to APB2 bus are called as APB2 domain. So that gets the clock from P clock 2, which is divided by APB2 prescalar. So now let me quickly talk about the PLL engine. Actually, we don't do coding on PLL in this course. That is actually covered in our next course, that is MCU2. Now, but let me briefly describe the PLL. PLL stands for phased locked loop, which is actually kind of clock multiplier engine of the microcontroller. The PLL engine, what you are seeing here, which is used to boost the clock to something higher than HSI or HSC. You can select a PLL as a source for the system clock. For example, let me select that here. Now you can see that here PLL has its own divisors and multipliers. The PLL works by taking a PLL source. For the PLL source, there are two options. Either you can use HSI or HSC. Here by default, PLL source is selected as HSI. And PLL has its own dividers and multipliers. This configuration shows that the clock for the sys clock will lead to 100 megahertz. Now you can even configure that. Let's say I can change this multiplier to, let's say, 50. So that way I can control the system clock. Or I can make it as 200 or something like that. So there are various registers of PLL by which you can configure all these values. You can see that there are a lot of red highlighted areas, isn't it? Here you can see that this software is saying that you cannot keep this as 2. Let's change this to 6 or something, or 2 or 4. So now here you can see that sys clock is boosted to 100 megahertz, right? From 16 megahertz of HSI. That was the source to the PLL, right? Now your processor is running at 100 megahertz. So otherwise it would have not possible if you have just used HSI or HSC, right? So that's the reason if you want to go beyond HSC and HSI, then only you have to activate the PLL. So now here you can see that there are two red areas, right? It is saying that you cannot clock P clock 1 above 42. That's the reason I have to now use Fourier. This is the right configuration. So that's the reason why PLL is used, in order to boost the HSI or HSC to some higher values. So now let's look at where you can configure all these prescalar values. As I said, it must be done in RCC peripheral register, right? Let's go to the reference manual and let's go to the RCC block. Go to the RCC register and here it is, RCC clock control register, right? So you have to read this section if you want to understand what different bit position means. So if you want to do PLL configuration, then you should be referring to the PLL configuration register. Let me take you to the RCC clock configuration register. So here is a place where you configure those AHB and APB prescalars. For example, let's browse through this document and here it is. So this is a place where you configure APB2 prescalar. That is this prescalar. And after that, this is a place where you configure APB1 prescaler. And this is a AHB prescaler. That is this one. So like that. So there are different registers. You just have to go through that and you have to configure the value. That's it. That's all you need to do. So that's how you derive different clocks for different domains of the microcontroller. Let's go back to our default one, that is HSI. So this is a default configuration. By default, AHB will be 1. So that's why you need not to do any AHB prescaler settings. By default, APB1 prescaler will be 1. And APB2 prescaler will also be 1. So that's the reason by default H clock will be 16 MHz, P clock 1 will be 16 MHz, and P clock 2 also will be 16 MHz. So you need not to do any configuration using your code if you are okay with these clock values. And also note that if you are using I2S peripheral, then clock for the I2S peripheral is actually derived from the PLL engine. So in this case, you have to activate the PLL engine. And also some peripherals such as USB or Ethernet or some other peripherals will not work fine if you underclock them. So in that case, it may be required to activate the PLL to provide the sufficient clocking values. So with that note, I would like to end this video and I will see you in the next lecture. In the next lecture, let's learn how to control the clock for the individual peripherals.